All right, ready to dive deep into something kind of sci-fi, like picturing the universe as a giant web of interconnected threads.
Fascinating concept, right? What's really cool is you, our listener, send in some thoughts and questions after hearing a podcast episode that use the same analogy to, understand space and time.
Yeah, it seems like this whole thread idea really grabbed you, and I gotta admit, it's mind-blowing stuff. So, if I'm getting this right, the podcast used these threads to represent space itself. And time is like the force connecting and holding them all in tension. So like moving through space is kind of like traveling along these threads. And the faster you go, the more tension you create, almost like stretching a rubber band.
Exactly. And the really intriguing part is think about a black hole where
Okay.
gravity is super strong, right? The tension on those threads would be massive, almost like they're about to snap. It's a powerful way to visualize how warped space and time get around these incredibly massive objects.
Yeah, I love that. It really gets across how powerful gravity can be. But you took this analogy even further. You started wondering if we could somehow bypass the speed of light limit, not by moving ourselves faster, but by moving the universe around us, kind of like a cosmic treadmill where we just stand still while space-time itself shifts around us.
That's incredibly imaginative. And it actually kind of echoes some stuff in theoretical physics. You're basically describing something similar to the Alcubierre drive, a concept a physicist named Miguel Alcubierre came up with back in '94.
Now I'm really curious. Tell me more about this Alcubierre drive. How's it supposed to work, like, at least in theory?
So picture a spacecraft surrounded by a bubble of spacetime.
Right.
The Alcubierre drive wouldn't propel the craft through space. It would actually warp space-time around it, compress space in front of the craft, and expand space behind it.
So the craft is basically surfing on a wave of warped spacetime.
Exactly. The craft wouldn't move faster than light locally, but the warped space-time bubble around it would move faster than light. That's how it could cover huge distances in a short amount of time. It theoretically gets around those pesky limitations of special relativity. The craft stays within its own little bubble where the rules are, bent.
That's pretty wild. But
Yeah.
if it's theoretically possible, why haven't we built one yet?
Well, theoretically possible is very different from actually doable. The Alcubierre drive, while it works on paper, has some big hurdles. For one, it needs something called exotic matter. This is hypothetical stuff, matter with negative energy density. We don't even know if exotic matter exists, let alone how to make or use it.
And I'm guessing the energy needed to make this warp bubble would be astronomical, to say the least.
You could say that again. We're tapping energy levels way beyond anything we can even imagine producing with today's technology.
So a cosmic treadmill is a bit out of reach for now. But you mentioned something earlier that I think is crucial. Causality. The whole cause and effect thing. The basic order of events. You wondered if warping space-time locally instead of across the whole universe would mess with that order. You're already thinking about the consequences before we even know how to build the thing.
That's a really insightful point, and it shows a deep understanding of what this kind of technology could mean. And you're right, a localized warp bubble, like the one Alcubierre proposed, shouldn't disrupt causality. It only affects a small area of space-time. It's the bubble, not the craft inside, that's going faster than light. Cause and effect would still work within that bubble.
So we're basically making a tiny pocket universe where the rules are different without messing with the rest of the universe.
Yeah, that's a good way to think about it. There's also this idea of a horizon surrounding this warp bubble, kind of like the event horizon of a black hole. This horizon would stop information from leaking out and messing with causality in the rest of the universe.
I gotta admit, it's a lot to process, all this space-time bending. But it's incredibly fascinating. Makes you wonder what other strange things might be out there in the universe.
Absolutely. And speaking of strange things, you brought up another mind-blowing concept, the expansion of the universe itself, which, by the way, happens faster than the speed of light. It seems you're thinking about this in terms of faster than light travel, like if we could surf this expansion.
Yeah, that's a question I keep coming back to. If the universe can expand faster than light, couldn't we somehow, ride that wave?
It's a clever thought. And it points to a key difference. The universe's expansion doesn't actually break the laws of physics. It's the fabric of space-time itself that's expanding, not objects moving through it.
Because the rules are different when it's the playing field itself that's changing, not the players on it.
Exactly. Think of it like a ruler that's constantly expanding. The markings get farther apart, but they're not actually moving across the ruler. That's kind of what's happening with the universe. And that's why some things in cosmology can involve speeds faster than light without messing up our understanding of physics.
Okay, starting to see the difference. But how could we actually use this expansion for travel? Like, how do we surf it?
Well, imagine tech that could manipulate space-time in a specific area, creating a wave we could ride. Kind of like creating our own mini inflation event, like the rapid expansion in the early universe, but much smaller and, under control.
So instead of breaking the speed limit, we'd be like bending the rules of the racetrack.
That's the idea. And again, it wouldn't break relativity because the speed limit is for stuff moving within space-time, not for the expansion of space-time itself.
Okay, so we just need to figure out how to manipulate space-time on a cosmic scale. Piece of cake.
If only it were that simple. The real challenge is how to actually do it. Manipulating space-time like that would need, yep, you guessed it, exotic matter, and those crazy amounts of energy we talked about. Some scientists think we could maybe harness dark energy, the mysterious force behind the universe's accelerated expansion. But we barely understand dark energy. So, for now, it's all speculation.
Noticing a pattern here. Amazing possibilities, but challenges that seem impossible. Makes you wonder if we'll ever crack these cosmic codes.
I think it's more a matter of when, not if. Human ingenuity is pretty good at surprises.
You're probably right.
Yeah.
But before we get too far ahead of ourselves, let's look at some of your questions about relative motion. It seems like you're really thinking hard about this concept, which makes sense. It's one of the most mind-bending parts of relativity. And you brought up a great analogy. A surfer on a wave. You asked, do we struggle to grasp the concept of relative speeds? Is the wave carrying us, or are we moving independently? Is it truly the wave that possesses the speed, with the surfer's speed relative to the wave being negligible?
Those are great questions. And they show how hard it is for us to really understand relative motion. The surfer analogy is perfect because it shows the difference between motion relative to the wave, where the surfer is mostly still, just riding, and motion relative to the shore, where the surfer's moving fast because of the wave.
Like the difference between how fast the surfer's paddling versus how fast the wave itself is moving.
Exactly. Now, connect that to space-time warping. The wave could be a warp bubble or the universe expanding. The spacecraft, like the surfer, would barely move relative to the warped space-time, but from far away it looks super fast. It's the wave of space-time that makes it seem so speedy.
So speed is always relative to what you're comparing it to. Makes you wonder what speed even means on a universal scale.
Exactly. And that leads to some big questions about motion. Space-time itself can warp and move, carrying stuff along, just like a wave carries a surfer. There's no such thing as absolute motion. Everything is in motion relative to something else. That's a core part of relativity.
Lots to think about there. Okay, let's try another example from your notes. Someone walking on a moving train. You seem to be struggling with the idea that their speed isn't just the train speed plus their walking speed, especially as we get closer to the speed of light.
Let's break it down. Relative to the train, the person's speed is just their walking speed. But to someone standing on the ground, their speed would seem like the train's speed plus their walking speed. But this only works at normal speeds, like you pointed out.
Here come those tricky laws of special relativity again, huh?
You got it. When we're dealing with speeds close to the speed of light, things get weird. Velocities don't just add up like in normal physics because the speed of light is a hard limit. Special relativity has a special formula for adding velocities that makes sure the final speed never goes over the speed of light.
I'll take your word for the math there. But the bigger question, the one you're really getting at, is why this happens at the speed of light. What's so special about that speed?
That's the fundamental question, right? It all comes from the fact that special relativity says the speed of light is the ultimate speed limit for everything. Information, energy, matter. Einstein said the speed of light in a vacuum is the same for everyone, no matter how they're moving.
So even if you're on a spaceship going at 99% the speed of light, light from a stationary source would still look like it's going, well, the speed of light.
Exactly. That seemingly simple idea is a cornerstone of special relativity, and it leads to some crazy consequences.
Like the fact that speeds don't add up normally at super high speeds.
That's one. It also leads to things like time dilation and length contraction, which are pretty mind-blowing.
Okay, let's recap. Speed is relative, the speed of light is constant for everyone, and space-time itself can warp. Got it. But why is there this speed limit? What's stopping us from going faster and faster?
It's like the universe has a built-in speed governor. As you get closer to the speed of light, space-time warps around you, so time slows down for you relative to someone standing still, and your mass increases.
So the closer you get to the speed of light, the heavier you get, like some cosmic weight gain program.
In a way, yeah. And because you're getting heavier, it takes more and more energy to keep accelerating you. To actually reach the speed of light, anything with mass would need infinite energy, which is impossible.
It's like the universe is teasing us with the speed of light. It's there, we can see it, but we can never quite reach it because the rules change as we get closer.
That's a pretty good way to put it. Speaking of good ways to put things, let's go back to your spider threads analogy for spacetime. Remember, you imagined moving slowly through this space doesn't cause much disturbance, but as you speed up, those threads start to catch on you, stretching them tighter, especially if you have mass.
And then you asked, if something could go faster than light, would those threads snap? Would the object just disappear? Would it rip a hole in reality?
It's a cool thought experiment. What happens when we try to break that cosmic speed limit? But exceeding the speed of light is something our current physics can't handle. It's like asking, what's north of the North Pole? The question doesn't even make sense with what we know.
So a big fat cosmic, we don't know.
Exactly.
Good.
One of those mysteries at the edge of our knowledge. But instead of focusing on what we don't know, let's look at what we do know. Space-time is dynamic. It can be warped and stretched by mass, energy, and motion. Those warps are what we experience as gravity. And the speed of light is a fundamental limit, a cosmic speed bump that stops anything with mass from reaching or going beyond that speed.
Right. And we know that your spider threads analogy is a pretty good way to picture it all. Gets across how space-time acts, even if it's not a perfect representation of the math behind relativity.
Definitely. It shows how creative we can be in understanding these big concepts. Speaking of which, you went even further in your notes and thought about the idea of fine-tuning in the universe. The idea that these specific values of physical constants and how perfectly balanced all the forces are might mean there's more going on than just the laws of physics as we know them.
Yeah, it's like you're sensing a deeper layer to reality. Something beyond just equations and what we can observe. Something that might explain why the universe seems so perfectly set up for life as we know it.
That's the heart of the fine-tuning argument. It points out how incredibly precise the universe's fundamental constants and laws are. The strength of gravity, the mass of an electron, the speed of light. If any of these were even slightly different, the universe wouldn't be able to support life.
Okay, I'm with you so far. But how does this connect to our trusty spider threads? We've been using that to picture space-time, but can it help us understand this fine-tuning idea too?
Definitely think of those spider threads as the very fabric of space-time, the stage for everything that happens. If those threads were arranged differently, if the tension was different, the whole play would change. Stars wouldn't form, galaxies wouldn't come together, and life as we know it wouldn't exist.
So those threads aren't just holding the universe together physically, they're also shaping the conditions that allow for complexity, for life, for consciousness. It's like the universe is a giant loom, and those threads are weaving the tapestry of existence.
That's a beautiful way to put it. The fine-tuning argument suggests that the loom itself, the framework of space-time, might be the result of something more than just random chance.
But couldn't it just be luck? I mean, we're here, so the universe obviously got it right at least once.
It's possible. Some call this the weak anthropic principle. The idea that we see the universe this way because if it were any different, we wouldn't be here to see it. Kind of like winning the lottery and saying, well, someone had to win.
But some people argue that the odds of winning this cosmic lottery are so unbelievably small that it's hard to believe it was just chance.
Right.
That's where this strong anthropic principle comes in.
Exactly. That view says the universe has to be able to support life, that there's some underlying principle pushing it towards complexity and consciousness. It's a much bolder claim, one that makes us think about possibilities beyond the purely material world.
So, are we talking about a cosmic designer? A universal architect? A mind behind it all? Or something we can't even comprehend?
All those possibilities are on the table when we start thinking like this. Some see evidence of a greater intelligence in the mathematical beauty of physics. Others propose that consciousness itself might be a fundamental part of reality, and that the universe is, in a way, self-aware.
Wow, we've gone from warping space-time to talking about the mind of the universe. That's a long way from those spider threads.
It is, but I think the thread analogy still works. Remember, those threads represent the fabric of reality, how space, time, matter, and energy are all connected. The fine-tuning argument suggests that how those threads are arranged, the laws that govern them, might not be just random.
So are you saying those threads could be the fingerprints of a creator, the brushstrokes of a cosmic artist, the code of a giant simulation?
I'm not saying I have the answer, but I think we need to be open to these possibilities. When we look at how perfectly tuned the universe is, We have to consider explanations that go beyond what we currently know scientifically.
It's amazing how something as simple as an analogy like your spider threads can lead to such deep questions about reality and our place in it.
It shows how powerful our curiosity and imagination are. We can use them to explore even the biggest mysteries.
This has been an amazing journey, and I have to give you props, listener, for your insightful questions and for pushing us to think about these mind-bending concepts.
Yeah, your thoughts have been super thought-provoking and have really made our discussion better.
As we wrap up this part of our deep dive, I'm just in awe of how vast and complex the universe is.
And excited about all the discoveries we still have to make as we keep exploring.
So, listener, keep asking those questions, keep exploring, and keep that imagination going. Who knows what incredible breakthroughs are waiting for us? Until next time, keep looking up at the stars and thinking about those cosmic threads that connect us all.
Welcome back to our deep dive into some seriously mind-bending ideas about space-time and the universe.
I have to say, this is one of those deep dives that makes you rethink, like, everything you thought you knew about reality.
It's true. When you start thinking about relativity and what space-time actually is, it's humbling, but it's also really exciting to push the limits of what we understand.
Totally. And speaking of pushing limits, you, our listener, did an amazing job connecting different ideas and coming up with really insightful questions.
Yeah.
Like, you were really interested in how the universe expands faster than the speed of light. And you started thinking, could we use that for faster than light travel? Like, could we surf that expansion?
It's a great connection. And it highlights how different it is for objects to move through space versus how space itself expands. The speed limit from relativity applies to stuff moving in space-time, not to space-time expanding. It's like trying to swim against a current versus being carried by it.
That's a really helpful way to think about it.
Mm.
But what really got me was your question about manipulating that expansion, making our own little space-time wave to ride on.
Like a surfer.
Yeah, super interesting idea. It makes you think, what if we could use the fabric of the universe itself to travel? Some scientists even think we could maybe use dark energy, the mysterious force behind the universe's accelerating expansion, as a kind of fuel for that kind of technology.
So instead of breaking the cosmic speed limit, we'd be like changing the racetrack itself to make shortcuts.
Exactly. It's pretty mind-blowing. And while it's just theoretical right now, it shows how powerful our imaginations are when we think about what might be possible. Speaking of imagination, let's go back to your spider threads analogy for space-time. It's been super helpful for picture these complicated ideas. You imagine these threads being stretched by both mass and motion, which led to some great questions about how they both warp spacetime.
True. Your analogy captures how both mass and motion put tension on space-time, which leads to stuff like time dilation. It's like pulling a rope. You can make it tense by hanging something heavy on it or by moving your hand really fast along it.
And you had this really insightful question. If a bigger dent in the fabric means the threads are stretched more, wouldn't moving faster also stretch them, whether it's weight or speed doing the stretching?
You're absolutely right. Both a heavy object warping spacetime and an object moving super fast cause the threads to stretch in a similar way, leading to time dilation. The reason might be different, but the result is the same.
So a huge black hole with tons of gravity or a spaceship going almost the speed of light, both can warp spacetime and make time slow down. It's amazing that something as fundamental as time is affected by both mass and motion.
It really shows how deeply connected space and time are, just like Einstein's theory of relativity says.
We've talked about how big objects and fast speeds warp space-time, but you also asked a super important question about how stable this whole fabric is. You wondered, if space is full of these spider threads and everything with mass and energy is always pushing and pulling on them, wouldn't the whole thing be constantly rippling and distorting, creating chaos?
That's a really insightful question. It gets to the core of how gravity works in general relativity. The key is the scale of the warping. For everyday objects moving at normal speeds, the effects on space-time are super tiny.
So it's like those spider threads are really strong. They can handle little nudges here and there without the whole universe falling apart.
Exactly.
Hmm.
Imagine a huge trampoline. If you drop a marble on it, it barely changes. But if you drop a bowling ball, it'll sag a lot. Space-time is similar. The more massive something is, the more it warps the fabric.
So those little ripples and changes are happening all the time, but they're so small we don't notice them, and they don't really affect the universe as a whole.
Exactly right. It's only when we're talking about incredibly massive things like stars, black holes, or objects moving at relativistic speeds that those warps become noticeable and cause effects like gravity, time dilation, and the bending of light.
Okay, so space-time is super resilient. It can handle everyday bumps and wiggles. But thinking about your image of those threads snapping, if something goes faster than light, what would that even look like? Would the object just poof out of existence? Would it tear a hole in reality?
It's fun to imagine what would happen if we could break that cosmic speed limit. But as we've talked about, going faster than light is something our current physics just can't explain. It's like asking, what's north of the North Pole? The question doesn't make sense with the way we understand things.
So that's a big cosmic, we don't know.
Exactly. It's one of those mysteries that are right at the edge of what we know. But instead of getting stuck on what we don't know, let's think about what we do know. Spacetime is a dynamic fabric that can be warped and stretched by mass, energy, and how things move. Those warps are what we feel as gravity. And the speed of light is a fundamental limit, a cosmic speed bump that stops anything with mass from reaching or surpassing that speed.
Right. And we know your spider threads analogy is a great way to visualize all this. It captures how space-time acts, even if it doesn't perfectly match the complicated math of relativity.
Totally agree. It shows how powerful human imagination is for understanding these big concepts. And speaking of big concepts, you went even deeper in your notes. You started thinking about the fine-tuning of the universe, the idea that the specific values of physical constants and how perfectly all the forces are balanced might mean there's something more going on than just the laws of physics.
Right. It's like you felt there's a deeper level to reality, something beyond the equations and what we can observe, something that could explain why the universe seems so perfectly made for life as we know it.
That's the core of the fine-tuning argument. It highlights how incredibly precise the universe's fundamental constants and laws are: the strength of gravity, the mass of an electron, the speed of light. If any of these were even slightly different, the universe wouldn't be able to support life.
I'm with you so far. But how does this tie into our spider threads? We've been using that to picture space-time. Can it also help us understand this fine-tuning idea?
Absolutely. Think of those spider threads as the fabric of space-time itself. It's the stage where everything happens. If those threads were arranged differently, if the tension was different, everything would change. Stars wouldn't form, galaxies wouldn't come together, and life as we know it wouldn't exist.
So, those threads aren't just holding the universe together. They're also setting the stage for complexity, for life, for consciousness. It's like the universe is a giant loom, and those threads are weaving the tapestry of existence.
That's beautiful. The fine-tuning argument suggests that the loom itself, the framework of space-time, might be the result of something more than just random chance.
But couldn't it just be luck? I mean, we're here, so the universe obviously got it right at least once, right?
That's possible. Some call this the weak anthropic principle. The idea that we see the universe this way because if it were different, we wouldn't be here, like winning the lottery and saying, well, someone had to win.
But some argue that winning this cosmic lottery is so unlikely, it's hard to believe it was just chance. That's where the strong anthropic principle comes in, right?
Exactly. That view says the universe has to be able to support life, that something is pushing it towards complexity and consciousness. It's a much bolder idea, one that makes us consider things beyond the purely material world.
So we're talking about a cosmic designer, a mind behind it all, something we can't even comprehend.
All those are possibilities when we start thinking like this. Some people see a greater intelligence in the math of physics. Others think consciousness itself might be fundamental to reality, and that the universe is, in a way, self-aware.
Whoa. We've gone from warping space-time to talking about the mind of the universe. That's a long way from those spider threads.
It is, but the thread analogy can still work. Remember, they represent the very fabric of reality, how space, time, matter, and energy are all connected. The fine-tuning argument suggests that the arrangement of those threads, the laws that control them, might not be random.
So you're saying those threads could be the fingerprints of a creator, the brushstrokes of a cosmic artist, the code of a giant simulation.
I'm not saying I have the answer, but we should be open to these possibilities. When we look at how perfectly tuned the universe is, we need to consider explanations that go beyond what we currently know scientifically.
It's amazing how something as simple as an analogy, like your spider threads, can lead to such deep questions about reality and our place in it.
It shows the power of human curiosity and imagination. We can use them to explore even the biggest mysteries.
This has been an incredible journey.
Yeah.
And you, listener, deserve credit for your insightful questions and for pushing us to explore these mind-bending concepts.
Yeah, your thoughts have been super thought-provoking and have really enriched our discussion.
As we wrap up this part of our deep dive, I'm left feeling awe and wonder at how vast and complex the universe is.
And a sense of excitement for all the discoveries that are waiting for us as we keep exploring its mysteries.
So, listener, keep questioning, keep exploring, and keep that imagination going. Who knows what incredible breakthroughs are just around the corner? Until next time, keep looking up at those stars and thinking about those cosmic threads that connect us all. Welcome back to the deep dive, where we're going beyond the familiar into like the realm of what could be, speculation, possibility.
It's been quite a journey, right? Exploring the listener's ideas about space-time, relativity, all those mind-boggling implications.
And now we're entering this territory where physics meets philosophy like head-on. We're dealing with questions that have been around forever. Is there something more to the universe than we can see? Some deeper meaning, a purpose, a plan?
These questions have been around for ages, right? From like ancient philosophers to modern scientists. And you, our listener, seem to be drawn to these big questions too.
It's like you sense there's another layer to reality, something beyond the equations and the observations, something that might explain why the universe seems so perfectly set up for life.
That's the heart of the fine-tuning argument, right? It points to how incredibly precise the universe's fundamental constants and laws are. Gravity, the mass of an electron, the speed of light. If any of these were even slightly different, the universe wouldn't be able to support life as we know it.
Yeah. Okay, so I'm with you so far. But how does this connect to our spider threads analogy? We've been using that to picture space-time, but can it also help us understand this fine-tuning idea?
Absolutely. Think of those spider threads like the fabric of space-time itself. It's the stage where everything happens in the universe. If those threads were arranged differently, different tension, the whole play would be different. Stars wouldn't form, no galaxies, no life as we know it.
So those threads aren't just holding the universe together, like physically. They're also setting up the conditions for complexity, for life, for consciousness. It's like the universe is this giant loom, and the threads are weaving the tapestry of, well, everything.
That's a beautiful way to put it. The fine-tuning argument suggests that the loom itself, that framework of space-time, might be the result of something more than just random chance,
But couldn't it just be luck? We're here, right? So the universe must have gotten it right at least once.
That's one way to look at it. Some call it the weak anthropic principle. We see the universe this way because if it were any different, we wouldn't be here to see it. It's kind of like winning the lottery and saying, well, someone had to win, right?
But some people say the odds of winning this cosmic lottery are so ridiculously small, it can't be just luck. That's where the strong anthropic principle comes in, right?
Exactly. That view says the universe has to be able to support life. That something is pushing it towards complexity and consciousness. It's a much bolder idea. It makes us think about things beyond just the material world.
So we're talking like a cosmic designer, a mind behind it all, something we can't even wrap our heads around.
Those are all on the table when we start thinking like this. Some see a greater intelligence in the way physics works, in the math. Others think consciousness itself might be fundamental, and that the universe is, in a way, self-aware.
Wow, from warping space-time to the mind of the universe, that's a long way from those spider threads.
It is, but I think the analogy still works. Remember, those threads are the fabric of reality, space, time, matter, energy, all connected. The fine-tuning argument suggests that how those threads are arranged, the laws that control them, might not be random.
So are you saying those threads could be like the fingerprints of a creator, the brushstrokes of a cosmic artist, the code of a giant simulation?
I'm not saying I have the answer, but I do think it's important to consider these possibilities. When we see how finely tuned the universe is, we need explanations that go beyond our current scientific knowledge,
It's amazing how a simple analogy, your spider threads, can lead to such deep questions about reality and where we fit in.
It shows the power of human curiosity and imagination to explore even the biggest mysteries.
It's been an incredible journey. And a huge thanks to you, listener, for your thoughtful questions and for pushing us to explore these mind-blowing ideas.
Absolutely. Your thoughts have been so thought-provoking, really added to our discussion.
As we wrap up this deep dive, I'm left feeling a sense of awe at how vast and complex the universe is, and also a sense of excitement for all the discoveries that are still out there waiting for us.
I agree. There's so much more to explore and understand.
So to our listener, keep asking questions, keep that curiosity alive, and never stop imagining. Who knows what incredible breakthroughs are just around the corner. Until next time, keep looking up at those stars and pondering those cosmic threads that connect us all